Welcome, math lovers. So, meeting you after some time with a nice Olympiad level question. A road as houses numbered from 1 to n, where n is a three-digit number, exactly 1 by k of the numbers starting with digit 2, where k is a positive integer. Find the possible value of n. Since they mentioned n is a three-digit number, so the smallest is 100. When we keep n as 100, then if we talk about the numbers starting with 2, then we will be noticing 2 on the series of 20, 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29. So this 11 numbers are the numbers that will start with 2. If I apply on this condition, that is 1 by k of this three-digit number 100 being equal to 11, you will understand that k cannot be a natural number. So if it has to be 11, so until we reach to 200, there is not going to be any number which will start with the digit 2. This 11 is fixed then. This is not going to change at all. This 11 will be fixed. So we can understand until 200. Until 200, we can rewrite this as 11 times k is equal to that three-digit number. So 11 multiple in a three-digit number form. So that makes our work easier. So this number value can be 110, 121, 132, 143, 154, 165, 176, 187, 198. So this will be the possible values of n until 200. By the moment we reach 200, things are going to change. The reason for it to change is because it will keep adding up to the number of values. The right side will keep increasing. And the how much ever increase in the right side, same thing will be found in the increase in here. So for example, I take 200. So within 200, we understand there will be inclusive of 200, there will be 12 values now. So far there were 11 values starting with digit 2. Inclusive of 200, there is going to be 12 values. From now on, it's going to be like increasing by, if this side increases, if the count increases by 1 year, meaning if we have 201 year, that means there will be one more number starting with digit 2, so that will become 13 year. So what we can do to handle the situation, we can introduce another variable to show if this side increases by some value a, and the other side also increases by the same value. So to include this 200 also as a value, what we'll do is, we'll just try to keep a greater than or equal to 0 as the condition for this question. So now you would notice if I cross multiply, I get 200 plus a is equal to 12k plus ak. So this gives us a very good opportunity to create a factorization expression. Okay, so I bring terms 12k plus ak minus a is equal to 200. So at the moment I notice in this I can take a common, so I'll get a times k minus 1. So if I want the same k minus 1 to be kept out common, so here this is I should be taking 12 common out of it. So I should be having 12k minus 12. So but minus 12 was not here. So I'm inserting minus 12 on both the sides of the equation. So this side will become 188. So this will become 12k minus 12, where you can take 12 common. So 12 times k minus 1. So k minus 1 is being common. So k minus 1 times 12 plus a is going to give us 188. We have a very beautiful number 188 on the left side, which can be factorized very easily as into 2 times 94, 2 times 47, and 47 is prime. So you have reached a golden thing. Because 12 plus a being greater than or equal to 0, 12 plus a will surely be greater than or equal to 12. So the factor that you're going to place here should definitely be greater than or equal to 12. So I can write it as, for example, 188 into 1. or then I can write 47 twos are 94 into 2, or then I can write 47 into 4. So this will be the only possible ways. You can write 188 here because I know 12 plus a has to be greater than or equal to 12. So now we'll take individually each of the cases. If 12 plus a is equal to 188, so this case will give a value to be equal to 176 and k value to be equal to 2. Further, I can take a, if 12 plus a is equal to 94, a value has to be equal to 82 and k minus 1 equal to 2, k value will become equal to 3. And further, if a value 12 plus a is 47, that means a value has to be equal to 35 and k value will be equal to 5. K minus 1 equal to 4, so k equal to 5. Now after this, okay, now this created three possible answers. This created three possible answers, meaning three possible values of n as well. So since a is 176, so you're reaching 200 plus 176 and 200 plus. So there is a limitation on a which I did not mention, because this increase on the right side will be happening only until I reach 99. So a should be less than or equal to 99 as well. So I should not be taking any value of a more than 99 with this condition, because after I cross 99, meaning 299, then I'll start reaching 300 and increase numbers. Okay. So I'll not be taking this case into account because here a value is 176. So I'll be taking only these two cases into account. So already you remember we had 11 values, 11 possible cases. Here we are having two more possibilities. So this tells us we can have 282 or 235 because A being 85, 82 or 35. So after this, after we cross 299, that means 300 until 999. So there will be no three-digit number starting with the digit 2, meaning it's going to be fixed. It's going to be very much fixed. So we understood the opportunity here. So whatever increase was there, so maximum, like this is going to be the highest value of A being 82, then K value became 3. So after this, what happens? So the number of values will be fixed only. So what I can write is the third case, 1 by K times any value from 300 and above. Okay, values above 300. Values above 300, it's going to be fixed. Now we can count it itself. 200 to 299, there were 100 values of n, which is starting with the digit 2, and before that we had 11 values. Before that we had 11 values, so altogether 111. So I'll write it here. This, as I said, this 111 will never increase because there is no more three-digit number which is going to start with the digit 2. So altogether it becomes 111k. It should be a value which is greater than or greater than 300. Okay, so this will create how many values of k? So greater than 300, my k value can be 3, 4, 5, 6, 7, 8, and 9. Because k being 3, you'll get 333, and k being 4, 444, k being 5, 555, so on till 999. So this creates us totally 7 values. So the question was how many possible values of n? So total is 11 plus, and in this scenario, we got 2 cases and finally 7 more cases. So 11 plus 2, 13 plus 7, 20. So 20 possible values of n is our answer.